So far, we looked at different types of probability. The most recent video, we did mutually exclusive. And in this one, we're going to be taking a look at a conditional probability. So let's go ahead and jump right in. So conditional probability is basically saying that what's the probability of something happening given that something else happens. We touched on this in an earlier video, but it's denoted by this A/B, meaning like A given B. So for instance, if I'm looking at this Venn diagram right here, I want to know the probability of A given B. So what it means essentially is that you take the intersection between two events and you divide it by the probability of this second event. And the answer that you might be or the question that you might be asking yourself is why? Well, let's take a look at A, B, and then, well, not A and B. So the probability of A happening given that B happens. So it's given that B happens, meaning that B has to happen. What that means is that basically B is now going to be your set of the total number of outcomes because it's happened. And it's also what you're kind of using as like your anchor, so to speak, because it's like, hey, given that this happens, what's the probability of something else happening? So given that it happens, meaning that we're going to take the 16 and 14 as our new denominator, 30. Now, what's the probability of A happening given that B happens? Well, if A is going to happen, given that B happens, it has to be the 16. Because B happens, meaning that these two values are taken into consideration, and then A happening is right here. That's where it intersects A, meaning that we would have 16. So again, this might look like a little bit of complicated writing, but basically all we're doing is we're taking the intersection, as I just explained, divided by the probability of B, which I just explained, and then this would now be your answer. Okay? Okay. Now let's take a look at a problem in context. Okay. So let's say that there's 84 teachers in a school, and of these teachers, 56 drink tea. We got 37 that drink coffee, like myself, and 12 that drink neither tea nor coffee. Actually, I'd be in the middle. Let's call this tea. Let's call this coffee. And okay, so 12 drink neither. Well, that's a pretty easy one to do. 12 are going to drink neither. And we know there's 84 total teachers, so 84 is the total number of people in my universe. So how many teachers drink both tea and coffee? Well, based off what we used last time in a previous video, we always want to kind of start in this middle. So if the middle is not given to us, we denote it by a variable. In this case, we're going to use x. So I'll say that x is going to be right here. And I know that 56 drink tea, meaning that this right here, which is drinking tea and only tea, is going to be 56 minus x. Okay, because I got to take out the ones that are going to be drinking coffee. 37 drink coffee, which means that 37 minus x would be the total that drink coffee and only coffee. So now I want to figure out how many people drink both tea and coffee, aka that x, the one in the middle of the Venn diagram. So what I can do now is just set up an algebraic expression, just as I did in previous videos, so that way I can figure out what x is and solve for the unknown. So I know that the total number of people in my sample right here is 84. So if I have 56 minus x that drink tea and only tea, x that drink both, 37 minus x that drink coffee and only coffee, plus the 12 that drink neither, that's going to be equal to 84 total people. And once you can use N-Solve or you can solve it by hand or put it in your calculator or whatever, you will find that the probability you find that x is going to be equal to 21. That's all it asks for. So before I even solve the rest of the problems, it's always best practice to go ahead and substitute this x value in for here, here, and here. So that way you don't really have to do that many calculations on top of other calculations. So if I have 21 that drink both, I would have 21 here. 37 minus 21 is going to give me a total of 16. And then here I'm going to have a total of 35. Not 25, 35. Okay, so let's say that, now we can get into the probability questions. So let me go ahead and label this B. The probability that someone chosen at random, one staff member at random, is going to drink tea but not coffee. So tea but not coffee is just this 35. So I have 35 people out of a total of 84. So again, in this case, we can't really simplify, but you could express this as a decimal or as a percentage. It just depends on what is required for you in the problem. So now let's go on to C. let's find the probability that if she's a tea drinker, she drinks coffee as well. So this is a conditional probability statement, even though it doesn't say given that. But if she is a tea drinker, or given that she is a tea drinker, that she drinks coffee as well. So if she is a tea drinker, meaning that she is going to be drinking tea, it means that we are selecting out of this pool of candidates, okay? So we have 35 and 21. That would give me a total of 56, meaning that my new denominator is 56. And then again, you can use the intersection formula here, or you can just realize that we are limiting our choices to this specific circle, and the ones that drink coffee would be 21. So that would give me the probability that given I have a tea drinker, that they drink coffee as well. So now if I move on to D, I'm saying that given that she is a tea drinker, she does not drink coffee. So again, I'm gonna have the same denominator, but now my option is gonna be, my numerator is gonna be 35. So I'm looking for 35 people that drink tea and only tea, given my total population that drink tea in total, which is 56. So that's how we can use conditional probability in terms of finding the probability, and also how it looks like in a Venn diagram. So I hope that helped, and I'll see you all in the next video.